Hello my dears. So what we studied in the last class? We studied about the instrument transformer, right? And I want to add one important question regarding the instrument transformer. That means the current transformer, my dear, the current transformer secondary terminal never open circuit. Never open circuit. This is very important question regarding the current transformer, because I already discussed to you. In current transformer, the secondary winding have very large number, huge number of turns are in secondary, which means a large induced EMF or voltage will be developed, because the voltage will be directly proportional to the number of turns. If number of turns increases, what happen in secondary, a huge voltage will be generated in kilovolt range it may be. So if it is open circuit, means across the terminal, my dear, across this terminal, what happened? Across the terminal, a huge voltage will be expected to be appear if it is open. So someone stand nearby may definitely get a shock or which is under risk. So what normally we have to do, we have to short circuit it with a very low resistance. That low resistance is nothing but, my dear, our ammeter itself. So the secondary of the current transformer is always what? Short circuited. Never it to be open circuited and operate. It is very risk. Okay, so that point you also you have to add. So today we are going to see another important session, which is nothing but, my dear, transducers. So what is mean by transducer? In electrical, normally transducer means, my dears, one form of energy to another form. That means a transducer is a device. Actually, it is a device which convert one form of energy to other form. That is transducer. In electrical or measurement system, the transducer means device which converts non-electrical quantities to electric quantities. Non-electrical quantities to electrical quantities, or vice versa. Transducer means not, that is inverse transducer. Transducer means which converts non-electrical quantity into electrical quantity. For example, thermocouple is an example of electrical transducer, because it converts the non-electrical quantity into electrical signal. Our microphone, or simply microphone or mic, what happen? Our sound energy is converted into electrical pulses. So that is a transducer. Is it clear? So any non-electrical quantity to electrical quantity, a device which is converting a non-electrical quantity to electrical quantity, such a type of devices is called transducer. And next one is inverse transducer. TD means transducer. Inverse transducer means what, my dear? Electrical to non-electrical. Example, piezoelectric crystal. What it does? Piezoelectric crystal, what it does? It converts the non-electrical quantity. Suppose you take a piezoelectric crystal and you apply some voltage along its terminal. What happened? Or along its side, it will produce mechanical vibration. Small mechanical vibration it will produce. That means it converted the electrical quantity to non-electrical quantity. Is it clear? Electrical quantity to non-electrical quantity. Is it clear, my dear? Is it clear? So that is an example of what? Inverse transducer. So many examples are there. You can solve by one. Okay. So electrical, this is what? Another is PV cell. This is also non-electrical to electrical. And Yes, that's all. Okay. And other name of this electrical transducer is that pickup. This also you have to note. Pickup is another name of the electrical transducer. Okay. Next, active and passive transducer. So active transducer means the transducer required energy for its operation. If a transducer requires some energy for its operation, then we call it as active transducer. For example, our strain gauge. Strain gauge means we will study later in this session. Also we will study that if you are changing the strain, the output to resistance will vary, so that its output will vary. That means strain gauge itself having certain voltage, we applied on certain voltage. If we change the strain, or we elongate or we compress the strain gauge, its resistance will vary. If the resistance is varying, its output voltage will also vary. So what we did, a transducer required energy. Now this transducer required energy, inbuilt energy is required for the conversion process or for producing the output. Such a type of transducer is called the active transducer. Okay. A transducer required energy for its operation. Okay. And this also includes the same, the PV cell also active. It required energy, na? It required energy in the sense it required sunlight for its operation, na? Sunlight. So it required energy. And piezoelectric transducer also an example. It requires energy for its operation. Okay, that is called the active transducer. Passive means opposite. Passive means opposite. Passive means what? It doesn't require energy for its operation. It doesn't require any energy for its operation. Is called the passive. For example, strain gauge. No. Strain gauge is not. Only PV cell. Strain gauge is here. Very sorry. So passive means it doesn't require any energy. For example, strain gauge. Strain gauge I will discuss later. It doesn't have, actually when it is in a circuit only it has certain voltage, but along the strain gauge it doesn't have any energy. Simply we have to elongate or compress the strain gauge, its resistance will vary. If something is connected to us, then using that we can measure the resistance all. But simply if a strain gauge, bare strain gauge means what? It doesn't require any energy. Okay, really sorry. It is actually not under, it is in passive strain gauge. It is in passive strain gauge. For example, thermistor. Okay. Thermistor means changing resistance with represent to the temperature is called the thermistor. Okay. It's all not that much important. It's a classification actually, not that much important. Next, primary and secondary transducer. Primary and secondary transducer mean, my dears, that means if a transducer, primary and secondary transducer means if a transducer converts the non-electrical quantity into electrical quantity in single step, it is called the primary transducer. It is called the primary. That means there is no intermediate steps. It directly converts the non-electrical quantity to electrical. For example, PV cell. PV cell means if you apply sunlight, it will definitely produce the output voltage. There is no intermediate stage at all, right? So example, PV cell. But secondary transducer means non-electrical quantity first converted into another non-electrical quantity then electric quantity. Is it clear? That means there will be intermediate states. That means if we give non-electrical quantity to a transformer, if it directly converted to electrical quantity, it is called the primary. But if we give some electrical input, non-electrical input, it converts that input into another non-electrical quantity. Okay, and then it is produced, the electrical output is called the secondary transducer. Okay, secondary transducer. Okay, next one, analog and digital transducer. That you know, that's it. Analog and digital transducer. So analog and digital transducer means, my dear, analog, you know this, the output will be in analog quantity or time varying analog signal, or digital means it will be the pulses in the form of a pulses. So it's called the digital transducer. Next, measurement of displacement. Measurement of displacement. Measurement of displacement. So for that, so many transducers are the LVDT, potentiometer, Hall effect transducer. Okay, clear? So let's see one by one. Okay, first of all, LVDT. First one, LVDT. No, correct. Induced EMF is ES1 and ES2. Correct now. very easy and very important also. So measurement of displacement, normally questions will be asked from this, generally. What is the transducer, the following transducer for the displacement? So if it is LVDT is there, tick that, okay. So LVDT means linearly variable differential transducer. What is that? Or simply linear variable differential transducer. What is that, my dear? Linear variable differential transducer. So in LVDT, it actually consists of two type of windings, similar to the what a normal transformer, my dear. It is transformer. So normal, according to the normal transformer, what is have the primary winding as well as the secondary winding. Here also the primary winding is there as well as the secondary winding is there. The action is similar to that of the transformer. It's nothing but the mutual induction. But the secondary whole of the secondary coil is divided into two parts. One is for producing certain voltage ES1 and another is producing certain voltage ES2, and the connections are made like this. And the output voltage will be nothing but what? ES1 minus ES2. That is the change in voltage will be the output voltage. And in between the primary and secondary coil, my dears, we are using nickel core. What is the function of the core here? The function of the core is to increases the flux density, correct? If the core is not there, then also mutual induction will be there. Then also induced EMF will be there in the secondary winding. But if the core is not there, the flux density in the air gap region will be very low, so that most of the fluxes will be lost as the leakage fluxes. So in order to avoid that, what happens, we have to use two secondaries and one core in between these two windings. So nickel is the very good magnetic material, so that it will increase the flux density, right? It will stop the leakage flux to the, that means the lines of force will feel more reluctance in the air gap or the air as a medium than the core, right? That means the core has less reluctance, so that the lines of force will easily go through the core, and there will not be any loss of flux lines through the surface, right? So that is the construction. So this is used for measuring the displacement. So displacement means it is a vector quantity, my dear. Displacement is a vector quantity. Am I right? Displacement is a vector. Means it have positive and negative values. Correct now? So displacement, you know this. Displacement means it is a vector. So vector means, of course, it have both positive and negative direction, or positive. Its magnitude will be positive as well as negative. Both will happen. Okay. So that is the vector quantity. So under normal condition, that means under equilibrium condition or null position, it's called the null position. That means there is no displacement. Displacement is equal to 0. Displacement is equal to 0 position. What happens? This nickel core, which is exactly midway between these two coils. Exactly, this is in mid between these two coils. So that equal EMF will be induced here and induced here. So that the difference in induced EMF will be 0. So output will be equal to 0 volt. There will not be any output voltage you measure here. Suppose I displaced this nickel core to the left of me by a small distance. What happened? There will be unbalancing in magnetic field lines associated with this first coil as well as the second coil. That means in first coil it moves towards the left, means more portion of the nickel core now included in the first coil, right? It was there first, so now it is moved here, means it moved like this, means the inclusion of the core or the vicinity or the presence of the core in second coil will be reduced, but the presence of the coil in first coil will be increased. So that what happened, towards left means ES1 greater than ES2, correct na? ES1 greater than ES2, so that implies V0 will be what? A positive quantity. V0 will be what, my dear? A positive. ES1 minus ES2. So ES1 greater than ES2 means E0, the output voltage will be positive. And if I displace it towards right, what happened? The flux linkage in the second coil will be increased. So ES2 greater than ES1, my dear. So that ES1 minus ES2 is negative. ES1 minus ES2 is negative. That means V0 will be what? Negative. V0 will be negative. So if the V0 is negative, means we can conclude that it is opposite to the conventional direction, or I can conclude that okay, the displacement is in opposite direction, because the output voltage having both direction, right? Its sign is changing. The meaning of its sign is changing is that there will be a displacement. If simply if it didn't connect like this, if you simply taking the output like, then we will give the distance, I mean according to the distance moved we will get the output. That is not the displacement. So the difference between displacement as well as the distance is that displacement means we can predict in which direction, towards east or towards west, towards north or towards south, so that we can explain the direction. But in the case of distance, my dear, speed, displacement as well as the distance, correct? Distance, what? We can't say the direction. Simply we can say 10 kilometer. So 10 kilometer is a distance, 10 kilometer north is a displacement. That is the difference. That is a difference, my dear. So simply 10 kilometer means it's a distance. So likewise, like that, simply some positive voltage, suppose simply some 5 voltage means it is corresponding to a distance. Suppose I indicating like a plus 5 volt, okay, it is towards left. That is in the chart already given along with the LVDT. We will get the chart like that, and we can find which direction is positive. And if it get negative means it is towards the opposite, it is towards the right. If positive means it is towards the left, and negative means towards the right. I mean 0 means it is exactly in center, so you can find the displacement. So I can say that the V out is directly proportional to what, my dear? Displacement. V output is directly proportional to what? Displacement. So that is the principle behind the LVDT. That is the principle behind the LVDT. Okay, and it have a lot of advantages. Advantage at high sensitivity. Even you can calculate from 100 micrometer to plus 100 micrometer you can measure. Okay, this much range you can measure, and high accuracy. So this is the range. Is the range and high accuracy. High accuracy, my dear. High accuracy. So these are the advantages of this transducer, and also no frictional loss, right? There is no heavy moving parts and all in this transducer, so there will not be any friction loss. And this output is, that means the sensitivity is given by, sensitivity of LVDT is given by, what is sensitivity means? It is nothing but the output by input, my dear. Here the output is a voltage, so it is output to voltage divided by input is the displacement, correct? Input is the displacement. So for LVDT, the sensitivity is given by, it is very important relation, my dear. For LVDT, the sensitivity is nothing but output to voltage divided by what, my dears? Displacement. Output to voltage divided by displacement is the sensitivity. Okay? Okay? Is it clear? Okay. Next, write a problem. The output voltage of an LVDT is (1.5 volt, comma, for a displacement of 10 mm. Find A sensitivity and B range of output voltage for displacement of a displacement of 2 mm. How can we solve, my dears? How can we solve? How can we solve? Actually, the power has gone. That is why there will be a dim of my board. Okay, the power has gone, but I don't want to stop it and I want to continue. Okay, even though there is no power. Okay, so that's why. So listen, the output voltage of an LVDT is 1.5 volt, my dears, for a displacement of 10 mm. So what is the sensitivity, my dears? What is the sensitivity? Sensitivity is nothing but what? Output to voltage divided by input is nothing but the displacement. So the output voltage is directly given now. So 1.5 divided by 10 mm. 1.5 divided by, so it will be 1.5 correct now? Correct. So you will get, you can directly in millimeter also you can get, or meter also. No, it normally in millimeter it is convention. If it is in meter also you can write, that is 0.15 volt per mm. Correct na? So that is the sensitivity, 0.15 volt per mm. And next, range of output voltage for displacement of 2 mm. If the displacement is 2 mm, then what will be the output voltage? That is simple. So what is not, sensitivity is constant, it won't change with time or something, right? It is constant almost. So the sensitivity is nothing but, my dear, so it is, we can write like 0.15 equal to output voltage divided by what? Displacement. Displacement is given for a displacement of 2 mm na? 2 mm. So the output voltage will be equal to 0.3 volt. correct? 0.3 volt. The output voltage will be what? 0.3 volt. That's all. Normally you can solve all that LVDT problems in millimeter because it is used to measure that much small distance now. So mm is not a problem while solving. Okay. Is it clear, my dears? Is there any doubt? Is there any doubt? Let me adjust my brightness. Let me adjust my brightness, my dears. Is it okay now? Almost? Okay? Is it clear now? Okay. So, next. The power is still not, it's not coming. Next, Hall effect transducer. T bar D means simply transducer, okay? Principle. Principle. Transverse magnetic field. Rheostat. These are my ideas. So let us first discuss what is the principle of Hall effect transducer, and then we can use this transducer for measurement of displacement. Okay. Listen. Listen, my dears. So normally the principle of Hall effect means if a conductor or a semiconductor, anything, if a conductor or a semiconductor placed in a transverse magnetic field and another direction, suppose we send some current through another phases of the transducer, then other phases, that means suppose this is the transducer, my dears. So 1 and 2 means the bottom and top of the transducer. Suppose it is in cubical shape. You imagine it is in cubical shape. So bottom and top of the transducer, in between that we send a current. Okay, and the phase of the transducer now, in perpendicular direction we send some magnetic field. So in 3 and 4 means the opposite direction, right? This is the current direction, this is the magnetic field direction, my dear. In the phase of the transistor, this piece of Hall effect crystal, it may be conductor or semiconductor, anything. So you send some magnetic field, the opposite end, the opposite side, that means the side 3 and 4. If you measure the voltage across these 3 and 4, there will be a small voltage, my dears. There will be a small voltage in the range of millivolt or very millivolt range, millivolt or microvolt range sometimes. So that voltage is called the Hall voltage, and there is an equation for Hall voltage, my dear. Hall voltage, EH will be is equal to Hall coefficient KH into I into B divided by T, where I is the current flowing and B is the flux density and T is the thickness. T is the thickness. So if you send these parameters, you will get an EH here. So initially when I read this, when I was in 12th, actually the Hall effect principle I studied in 12th. You also studied in 12th now. So at that time I never wondered. I thought, okay, if you send some current here, definitely some voltage will be there now. But I think later, see my dears, if I didn't apply any magnetic field, I simply apply some current here, what will be EH? If no signal or if no magnetic field, EH will be what, my dear? It will be 0, which means it is nothing but the surface of the conductor. If you send some current in the surface of the conductor, my dear, surface of the conductor, you send some current. If you put or if you measure the potential difference across any point of this conductor surface, you will get 0 potential, my dears. You will get 0 potential because along the surface of the conductor now there is potentially same. The ends of the conductor may be at different potential, but the surface, see the surface of the conductor, there will not be any potential difference. Correct na? So I can say that if there is no magnetic field, EH will be 0, but the presence of the transverse magnetic field, my dears, the transverse in the sense it is perpendicular to the surface. So the presence of the transverse magnetic field makes what? The voltage EH here. That voltage is called the Hall voltage. So all conductors and semiconductor will exhibit this property, is called the Hall effect principle. Okay. So I can say that across 1 and 2 I send some current I, across the phase okay, I can say that 1, 2, 3, 4 and 5 and 6, correct no? So this is 5 and 6. So 5 and opposite 6 I applied a transverse magnetic field, and across this 3 and 4 I get voltage. That is called the Hall effect voltage. This principle is called the Hall effect. This is called the Hall effect principle. Okay. So if the voltage, the voltage across these EH, across the terminal 3 and 4 is in suppose millimeter range, you can directly measure it with what? A MC instrument, a moving coil type instrument. You can directly measure. How can this Hall effect is utilized for finding the displacement, my dear? Find the displacement. Suppose my dear, you have, it is not asked, it will not be asked in your examination, but I will tell you that also. So this is the iron core, okay, or any magnetic material, and due to this there will be a transverse magnet. That means arranged to this piezoelectric actually, this Hall effect material is arranged so that the magnetic field will be directly in transverse direction. In that manner you have to arrange, and this is connected to any of the mechanical system, coupled to any of the displacement system. You coupled. Okay, this whole arrangement will be like this. The whole arrangement will be like this, and across this and this you will get EH and all. Okay, that's fine. So the whole arrangement will be like this. So if you displace this magnetic material in small distance, what happens? This magnetic flux will be varying. This magnetic flux will be varying. If the magnetic flux is varying, it is directly affecting the Hall voltage. So the displacement of the magnetic moment, magnetic material movement can be indirectly found out by what? The Hall effect material. That is how you have to measure the displacement. Okay? Is it clear? Is it clear, my dear? So that's all. And the applications of this means the applications of this Hall effect transducer is applications to find B, I, displacement, B, I, displacement. Okay, that's it. And nature of the semiconductor. Nature of semiconductor, etc. etc. Okay, so that's all about the Hall effect. Next one is potentiometer transducer. Potentiometer transducer. See, my dears, potentiometer is nothing but a resistance is adjusted in such a manner that if a slide wire is conducted across the resistor, and if a slide wire moves, the output voltage also move, different. The output voltage also increase or decrease depending upon the movement of the slide wire on the surface of a resistor. That's called the potentiometer transducer. Okay, and let's see how this transducer is used to but measure the displacement. That's our aim, right? So we will know what will be the current I will be. I can write I will be equal to what, my dear? V by R, na? The total voltage V divided by the resistance R. For R, resistance is for L length. R resistance is for L length. R1 resistance is for L1 length. That's all. That means there will be what? Okay, limit. Note. It will make you confused. So it will be equal to again V1 divided by L1. V1 divided by L1. Okay. I is equal to V by R, or okay, symbol. So I will be equal to what, my dear? V by R, and it is, I can write like let's say V, which is proportional to V divided by L. Because for L length, my dear, the resistance is R. So that is R and L are directly proportional. R is equal to rho L by N. So R and L are directly proportional. So I can write like, which implies R proportional to L. Correct? R proportional to L. So what is the output voltage here? Output voltage I can write like, output voltage is nothing but, my dear, V0 is equal to I into R1. I into R1. Am I correct? Suppose I am taking the output voltage from here. This current is like I. There is no change in that. Into R1. So I is nothing but what? V by L into R1 is nothing but what? R1 is directly or I can write simply like proportionality. V0 will be I into R1 proportional to I is proportional to V by L na, I is proportional to V by L na, V by L. So V by L into R1 is proportional to L. This V is a constant na. This L is total length is a constant na. This L1 only we can change, right? So I can say that the output voltage is directly proportional to the displacement. That's a simple principle, my dear, simple principle. If you vary the distance, the output voltage also varies, that's all. If you vary the distance, output voltage also vary, simple. So here also the sensitivity of the potentiometer transducer is that output voltage divided by displacement. Is it clear, my dears? Is it clear? That's all. See, today's class is actually the miscellaneous topics, not that much important topic, but if asked, you can answer. That's all. Next, some important terms you have to note. Pressure is nothing but, my dear, force by area. Stress, again, force by area. Strain, change in length by or changing dimension by original dimension. Change in dimension by original dimension. Young's modulus. Stress by strain. Young's modulus is nothing but, my dear, stress by strain. So, okay, that's all. And Poisson's ratio. Lateral strain by longitudinal strain. For that, consider this, my dear. Draw this. Okay, now it is not needed now. For next, I will draw. For strain gauge, it is clear. So now up to now it is clear now. Lateral strain by longitudinal strain. That's all. Next, strain gauge. Okay, this definition you should know. Next is strain gauge. Strain gauge. What is the time now? Time now. Is there? Time is there. Strain gauge. GAUG. Okay. Strain gauge. Draw this figure. ADS. other name is piezo resistance transducer. Piezo resistance transducer. So what happened means, listen. So strain gauge is nothing but, my dear, suppose this is initially with a diameter d. Suppose you take a material, a conductor, initially with a diameter d and initially with a length L. If you structure this conductor, what happened? Its area of cross section will be reduced, its length will be increased. The diameter will be reduced like not d but d minus d will be the new diameter, and the length will be increased to L plus delta L. So strain is nothing but what? What is the expression for strain? Strain is nothing but changing dimension by original dimension. So here let you mark this delta L changing length, delta D change in diameter, and delta R change in resistance. Change in resistance. So only one thing you have to note here, what is gauge factor here? Gauge factor here. So gauge factor is nothing but, my dear, lateral strain divided by longitudinal strain. Lateral strain means the change in the diameter divided by original diameter. Longitudinal means change in the length by original length. So that is the equation for gauge factor. That is the equation for gauge factor. Okay. So sorry, my dear, it is not gauge factor, it is Poisson's ratio. It is Poisson's ratio. Okay. And gauge factor is nothing but GF is equal to delta R by R divided by delta L by L. It's very, very important. From this session, only this point is very, very important. This is directly asked in the university examination. You know, university competitive examination. What is the expression for gauge factor? Changing resistance with representation to the original resistance divided by changing length by original length. Or this can be also write like gauge factor is equal to delta R by R divided by changing length by original length is nothing but, my dear, strain or longitudinal strain. Okay, that also you can explain like this. Okay, and generally gauge factor is equal to 2. The common value of gauge factor is nothing but 2. That also you can note. That's all about the topics. Okay, and let's discuss some small topics. Some small topics. Some small topics, my dears. First one, unit of small pressure. Unit of small pressure, it is micron. That is 1 micron equal to 1 torr equal to 1 mm. This you have to note. This you have to note. And Pirani gauge, there is an instrument called Pirani gauge used to measure low pressure. What it is used for? For measuring low pressure. seismic transducer for mechanical vibration. For vibration measurement. And RTD, temperature up to 600 degrees Celsius. Thermistor, temperature dependent. I mean, thermistor means if it is increasing, temperature is increasing, its resistivity will decrease. That is called a thermistor. And this thermistor is used for resistance, positive and negative range. Not measuring temperature, temperature in negative, positive and negative range. And thermocouple, utilizing Seebeck effect. Temperature up to 1400 degrees Celsius. Pyrometer, measure ultra high temperature. Without touching the body, without touching the body. Okay, so these are some important points in measurements. So here I am going to wind up the measurement session, and from tomorrow onwards we will discuss analog electronics. It's very, very important, analog electronics. Okay, and later on we will go to power system and all, definitely. Okay, and control system is there. Very, very big subject is control system. So I am taking not for the, I'm saying repeatedly, this is for the competitional, I mean competitive exam point of view, my dears. If you really want to know more about the theory, you have to refer some books, right? But this is for actually you have a small base. If you pass, at least you pass about BTech now, so you should have some base. So from that base you can develop these ideas. Okay, that is the intention. So if you really want to know the more theory, for example thermistor, thermocouple, detailed theory and all, then you have to refer books. But it will take more. It is a wastage of time now. You refer previous question paper, you will see the magic. If my notes, if you study my notes, my dear, if you study my measurement notes, check the previous year question paper, you will see the magic. You will see how can you solve that questions and all. Okay, so depending upon the competitive examination point of view, I am taking the classes. Okay, so that's all for today, my dears. So the power is also but a headache now, so it almost half an hour, more than half an hour, it's not there. So that's why the board is slightly not clear. So please cooperate. Anyway, we will meet tomorrow with a new subject. So until then, bye, take care.